So we're going to start our discussion of ordering by looking at the ordering of results for Java collections. And you'll see that the choice of collection you make has an effect on the order in which results will be presented once the stream is finished running. And we'll take a look at a bunch of different examples. You can find all of these examples in my EX21 project, in my Java 8 folder, in my Live Lessons repository. So let's talk about how collections matter when it comes to order. So remember, I've talked before about the concept of encounter order. Encounter order just means that we're going to keep track of the order in which things are encountered from left to right, if you think about it that way, from the beginning of the collection to the end. And things that maintain encounter order include ordered split arrators. We'll talk about what that means in a second. Ordered collections, which also use ordered split arrators, and static stream factory methods. And this is the little program we're going to use in order to demonstrate how this stuff works. So in this particular case, we make ourselves a list using the asList method, which takes this array. The array is 2, 3, 1, 4, 2, of course. And it's going to make a list of those things. And an array list, which is what this thing comes back as, is ordered and non-unique. Those would be the flags, by the way, that would be set internally to indicate that. So even if we're going to take this list and run it in parallel, that order will still be preserved by the time we're done with the results. Remember, by the way, that ordered is not the same thing as sorted. Unfortunately, we use the word order also to mean sort. But sorted means they're sorted. These are clearly not sorted. But they are ordered in the sense that 2 comes before 3, which comes before 1, which comes before 4, which comes before 2. So that's what ordered means. So in this particular case, we're going to only allow even numbers to continue through the stream. So if you mod the value of one of these things by 2 and you get 0, that's an even number, so that can continue. We're then going to go ahead and multiply even numbers by 2. And when we're done, we're going to create an array of integers. That's what this terminal operation does, toArray. It creates an array of integers, and that's what gets stored here. And so the results of this thing must be 4, 8, 4, because we only keep even numbers, and the first even number was 2, the second even number was 4, and the third even number was 2. So we multiply all this by 2, we end up with a result 4, 8, 4. And because of the properties of the list, the array list, because list is an ordered collection, we know that the results have to be that. We don't care the order in which these computations take place. Those can take place in any old order we don't care. Any old order that the Java Streams Common Fork Join Pool decides, that can be done in whatever order it chooses. But we want the results to be ordered. And they are, because that's preserved by the semantics of a list. So let's take a look at a different example. And this one uses unordered collections. And in particular, we're going to use a hash set. And we're going to see that those don't need to respect the encounter order. So remember that a hash set, unlike a list, is unordered and unique. So what that means is we don't care about the order because it's hashed. So there really isn't any particular order. But it is unique because it's a set. So we take 2, 3, 1, 4, 2, and that'll, of course, be a set that's not ordered, and it'll only have 2, 3, 1, 4. There won't be a duplicate 2 because it's unique. Now, you won't see this from an example with 4 elements or 5 elements in it, but if you had an example with thousands of elements, which is actually what happens when you run my test program in the EX21 project, you will possibly get faster, better behavior because encounter order need not be maintained in the results. So the results could come back from this as being either 8, 4 or 4, 8, depending on the order in which the computations occur. So the nice thing about that is that you get more flexibility. You, the user, get the benefits of Stream's flexibility in running things in any order and not caring about encounter order being maintained. You can get better behavior because you don't have to worry about recombining the results at the end. So that's the end of the overview of how collection choice will affect the ordering of results.